You need to hear this if you have ever stood under the night sky and wondered what is really out there. Imagine yourself beneath a blanket of deep velvet, scattered with countless shining stars. Now, what if I told you that hidden among them are astonishing secrets, colossal black holes bending space and time, stars bursting into life and dying in spectacular supernovas, and faraway worlds that might be alive with possibilities? This is more than just a trip through space. It is a journey into the heart of existence, showing us our place in a universe far more mysterious and breathtaking than we can imagine. So get ready to open your mind, spark your curiosity, and see the meaning of home in a completely new light. The Milky Way is our galaxy. It is a vast, spinning island of stars, gas, and dust in the immense ocean of intergalactic space. Our Sun is just one of at least 100 billion stars that call this galaxy home. And our Earth is just one of a potentially even greater number of planets orbiting those stars. Everything we have ever known, every person who has ever lived, every story ever told has happened right here, within this incredible cosmic structure. It is our home on the grandest possible scale, a place of staggering beauty and complexity which we are only just beginning to understand. Imagine a city of stars, a sprawling metropolis of light and gravity. The Milky Way has a distinct structure, just like a city. It has a bright, dense central hub, which we call the galactic bulge. This region is packed with ancient stars, all swarming around a mysterious, powerful heart. Extending from this center are great sweeping arms. These are the suburbs of our galaxy. These spiral arms are where the action is. They are rich in gas and dust, the raw materials for creating new stars. Our own solar system is located in one of these arms, quietly orbiting the distant galactic core. But the stars and gas we can see are only part of the story. The Milky Way is far more massive than it appears. Scientists believe that most of our galaxy is made of a mysterious, invisible substance. They call it dark matter. We cannot see it. We cannot touch it. It does not emit any light or energy, yet we can detect its powerful gravitational influence. It forms a vast spherical halo around the visible parts of the galaxy. It is the invisible skeleton that holds our entire galactic island together, preventing the stars from flying apart as they spin. So when we speak of the Milky Way, we are talking about a truly colossal entity. It stretches over 100,000 light-years from one side to the other. A light-year is the distance light travels in a year, which is nearly 10 trillion kilometers. To cross our galaxy would take a spacecraft traveling at the speed of light, 100,000 years. It is a scale that defies our everyday comprehension. Yet, this is our home. This is our neighborhood. And it is filled with more wonders than we can possibly imagine, waiting to be explored. Our journey will not be a short one. It is an odyssey that will take us across unimaginable distances. We will travel from our familiar cosmic backyard to the most extreme and exotic places in our galaxy. Our voyage begins right here, in our own solar system. We will leave our blue marble, Earth, and travel past our planetary neighbors. We will cross the asteroid belt and visit the gas giants. We will venture out to the icy realms of the Kuiper Belt and the distant mysterious Oort Cloud, the very edge of the sun's gravitational influence. This is the first step on a much grander expedition. From there, we will take the ultimate leap. We will travel into interstellar space. Our first destination will be our closest stellar neighbor, the Alpha Centauri system, a triple-star system that may harbor worlds of its own. We will meet other nearby stars, both bright and dim. We will visit stellar nurseries like the Great Orion Nebula, where clouds of gas and dust are collapsing to form thousands of new suns and planets. We will witness the life cycle of stars. We will see their brilliant births and their spectacular, explosive deaths in supernova events that seed the galaxy with the elements for new life. Our epic voyage will then take us deeper towards the very heart of the Milky Way. We will encounter cosmic giants, stars so large they would swallow our entire solar system. We will navigate through dense star fields and ancient globular clusters, relics from the galaxy's birth. And then, we will face the ultimate mystery. We will travel to the galactic center to meet the supermassive black hole that lurks there, a gravitational monster known as Sagittarius A Star, whose pull governs the orbits of billions of stars, including our own sun. It is a journey into the most extreme environment our galaxy has to offer. This is an invitation to join us on a grand tour of our galactic home. We will explore its structure, from its sweeping spiral arms to its hidden halo of dark matter. We will uncover its history, from its violent birth billions of years ago to its ultimate fate in a cosmic collision with a neighboring galaxy. This is the story of the Milky Way, but it is also our story. By understanding our galaxy, we can better understand our own origins and our place in the universe. So, buckle up. The greatest journey of all time is about to begin. At the heart of our solar system blazes the sun, our anchor, furnace, and guiding light. It holds over 99% of the system's mass, its gravity binding planets and dust alike. Every second, nuclear fusion in its core releases energy that warms our world and fuels life. Yet the sun is dynamic and sometimes violent, shaping the rhythm of our lives. As we journey outward, we follow its light to the worlds that dance in its eternal glow. The inner solar system is home to 4 rocky worlds: Mercury, Venus, Earth, and Mars. Each is unique: Mercury scorched and cratered, Venus shrouded in toxic clouds, Earth vibrant with life, and Mars a cold desert with hints of ancient water. Together, they reveal the diversity and wonder of our solar family. Now, we journey onward, across the vast space beyond Mars. Before reaching the outer giants, we cross the asteroid belt, a vast, mostly empty region of rocky debris between Mars and Jupiter. Beyond lies Jupiter, the largest planet, a gas giant of swirling clouds and storms. Saturn follows, famous for its breathtaking rings. Farther out, Uranus and Neptune, icy, distant, and mysterious, complete the realm of giants. Beyond Neptune lies the Kuiper Belt, a vast, frozen realm of icy bodies and dwarf planets like Pluto. Here, the sun is just a distant star, and ancient objects remain unchanged for billions of years. Some become comets, journeying toward the sun and lighting up our skies. The Kuiper Belt marks the edge of the planetary region, a frosty frontier and a gateway to the unknown. Our solar system is wrapped in a vast, invisible bubble, the heliosphere, created by the sun's solar wind. This cosmic shield protects us from harsh radiation and cosmic rays, making life on Earth possible. At its edge, the sun's influence ends, and the true realm of interstellar space begins. We have traveled beyond the planets, past the Kuiper Belt, and into interstellar space, yet the sun's gravity still lingers. Here lies the Oort Cloud, a vast spherical shell of icy objects, the solar system's final frontier. Its edge may reach a quarter of the way to the next star. From here, the sun is just another star, and the planets are lost in darkness. We have crossed the sun's domain. Now the true void between stars awaits. We stand at the edge of our solar system, ready for the first true leap into interstellar space. Our destination, Alpha Centauri, over 4 light-years away. Even at light speed, the journey would take years. As we travel, our sun fades behind us, and a new star grows brighter ahead. We have arrived at Alpha Centauri, our first port of call among the stars. At the heart of Alpha Centauri lies a stunning binary pair, Alpha Centauri A and B. From afar, they shine as one, but up close, they're 2 suns locked in a graceful dance. These stars, so close to our solar system, remind us that many worlds may orbit 2 suns, not just one. Our closest stellar neighbor is Proxima Centauri, a faint red dwarf orbiting the Alpha Centauri A and B pair. Just over 4 light-years away, Proxima is invisible to the naked eye, glowing dimly in the vast darkness. Red dwarfs like Proxima are the most common stars in our galaxy, long-lived but volatile. Their powerful flares can strip atmospheres from nearby planets, making life a challenge, but not impossible. In 2016, astronomers discovered Proxima b, the closest known exoplanet to Earth, orbiting the red dwarf Proxima Centauri. This rocky world lies in the habitable zone, where liquid water could exist. But Proxima b faces harsh radiation and extreme conditions. Its discovery inspires dreams of interstellar exploration and a future among the stars. Visiting the Alpha Centauri system, even in our imaginations, forces us to confront the single greatest barrier to humanity's expansion into the galaxy, the sheer, overwhelming scale of interstellar distance. The energies required to propel a spacecraft to even a fraction of the speed of light are astronomical, far beyond anything our current technology can achieve. The Voyager 1 probe, one of the fastest objects ever launched by humans, is traveling at about 17 kilometers per second. At that speed, it would take over 75,000 years to reach Proxima Centauri. This is the tyranny of distance, a fundamental challenge imposed by the laws of physics. To make the journey within a human lifetime, we would need to develop revolutionary new forms of propulsion. Chemical rockets, which have taken us to the Moon and Mars, are simply not powerful enough. Scientists and engineers are exploring more exotic concepts. Solar sails could use the pressure of sunlight or powerful ground-based lasers to slowly but steadily accelerate a craft to incredible speeds. Fusion rockets, harnessing the same energy that powers the stars, could provide immense thrust. Even more speculative ideas, like antimatter engines or physics-bending warp drives, populate the frontiers of theoretical science, offering hope for a future where interstellar travel is a reality. Beyond the challenge of propulsion, there is the problem of time. Even at near-light speeds, journeys to nearby stars would take years. The crew would have to endure long periods of isolation in a confined space, far from home. This raises profound biological and psychological challenges. Would it be possible to use suspended animation or hibernation to pass the long years? Or would these missions require multi-generational ships, where the descendants of the original crew would be the ones to finally arrive at their destination? These are no longer just questions for science fiction, but are becoming serious topics of scientific research. Finally, there is the danger of the journey itself. Traveling at relativistic speeds makes even the smallest speck of interstellar dust a deadly projectile. A collision with a grain of sand could release the energy of a bomb, catastrophically destroying the spacecraft. Any interstellar vessel would need incredibly powerful shielding or an advanced system to clear its path of debris. The Alpha Centauri system, our closest neighbor, serves as a powerful symbol. It is both a tantalizing destination, beckoning us forward, and a stark reminder of the monumental technological and human challenges we must overcome before we can truly call ourselves a star-faring species. Leaving Alpha Centauri, we journey to Barnard star, an unassuming red dwarf, but the fastest-moving star in our sky. Its rapid motion is a cosmic illusion, a result of its speed and proximity. Barnard star is a visitor from the galaxy's ancient halo, racing through our neighborhood. Watching it, we glimpse the ever-changing dance of our galaxy. Barnard star is an ancient red dwarf, smaller and cooler than our sun, burning its fuel slowly for billions of years. Its calm, faint red glow has witnessed the galaxy's history unfold. Studying its light, we glimpse the early universe, a living fossil, quietly enduring as brighter stars are born and die. Barnard star has long fascinated astronomers searching for exoplanets. Early claims of planets proved to be errors, but the hunt continued. In 2018, a possible super-Earth was announced, only for later studies to cast doubt. The search for worlds around this nearby star remains ongoing, a testament to science's persistence and self-correction. Our solar system is part of a dynamic, ever-shifting community of stars. Some, like Alpha Centauri, are long-term companions. Others, like Barnard star, are just passing through. Over millions of years, our night sky will change completely. We are all passengers on this magnificent galactic carousel, journeying together through the Milky Way. Leaving the dim red dwarfs behind, we approach Sirius, the brightest star in Earth's night sky. Just 8.6 light-years away, Sirius dazzles with unmatched brilliance, outshining our sun 25 times over. For millennia, it's been a celestial landmark, guiding travelers, inspiring myths, and marking calendars. Now we see Sirius not as a distant beacon, but as the powerful, dynamic star it truly is. For centuries, Sirius seemed a single star, but astronomers noticed a strange wobble, evidence of an unseen companion. In 1862, a faint pinpoint, Sirius B, was finally spotted beside the brilliant Sirius A. Sirius A shines bright, while Sirius B is a tiny, dense white dwarf, once a giant, now a cosmic ghost. Sirius B is the first white dwarf ever discovered, a tiny super-dense stellar corpse glowing with leftover heat. Its surface blazes at 25,000 degrees Celsius, hotter than our sun, yet it's faint and hard to spot beside Sirius A. Supported by quantum pressure, Sirius B is a glimpse into the sun's distant fate, a reminder that even stars must die. Sirius is our brightest star, but it's not alone. Nearby, Procyon and Altair shine brightly. Procyon is a binary, Altair spinning rapidly, and Vega with its dusty disk. These stars, our luminous neighbors, have guided humanity for millennia and may one day be our first destinations among the stars. Journey with us over 1,000 light-years from Earth to the iconic constellation of Orion. Orion's brilliant stars form the shape of a great hunter, a celestial landmark for stargazers across generations. These stars are born from the same colossal cloud, shining with youthful energy and illuminating vast clouds of gas and dust. Orion is a living masterpiece, dynamic, beautiful, and ever-changing in our galaxy. Our first stop in Orion is Betelgeuse, a red supergiant glowing fiery orange-red. If placed at our sun's center, Betelgeuse would engulf Mars and reach Jupiter. In 2019, it dimmed dramatically, sparking supernova speculation. One day, Betelgeuse will explode as a supernova, outshining every star in the Milky Way. Its end will seed the cosmos with new elements, fuel for future stars and life. From Betelgeuse, we journey to Orion's belt, 3 brilliant stars, Alnitak, Alnilam, and Mintaka, shining as a near-perfect line in our sky. These blue supergiants are young, powerful, and far more massive than our sun. Alnilam, the central star, is a true titan, radiating with the light of hundreds of thousands of suns. Their energy shapes glowing clouds and nebulae, a cosmic signpost for travelers across the galaxy. Hanging below Orion's belt is the Orion Nebula, a vast, glowing cloud of gas and dust. It's the closest large star-forming region to Earth, a true stellar nursery. Here, thousands of new stars are being born, their light illuminating the nebula's breathtaking colors. At its heart, the trapezium cluster's young hot stars power this cosmic beacon, showing us creation in action. Our visit to the Orion complex, from the dying giant Betelgeuse to the newborn stars of the Orion Nebula, reveals a profound and fundamental truth about the universe. The cosmos is locked in a perpetual cycle of creation and destruction. Stars are born from vast clouds of gas and dust. They live their lives, shining for millions or billions of years, fusing lighter elements into heavier ones within their fiery cores, and then they die. For the most massive stars, like those we have seen in Orion, this death is a spectacular supernova explosion, an event of unimaginable violence and power. This destructive end, however, is not a finality. It is a crucial part of the creative cycle. The supernova explosion blasts the heavy elements that were forged inside the star, elements like carbon, oxygen, silicon, and iron, out into the galaxy. These elements enrich the interstellar medium, seeding the clouds of gas and dust with the raw materials necessary for the next generation. All the heavy elements that make up our planet, the iron in our blood, the calcium in our bones, and the carbon in our DNA, were created inside a massive star that lived and died long ago. We are, in a very literal sense, made of stardust. The shockwave from the supernova itself can become a creative force. As it expands outwards, it plows into nearby clouds of gas, compressing them and triggering their gravitational collapse. This collapse is the first step in the formation of new stars and new planetary systems. The death of one star can therefore directly trigger the birth of hundreds or thousands of others. In this way, the galaxy is constantly recycling its material. Destruction gives rise to creation in a grand cosmic loop that has been repeating for over 13 billion years, slowly making the universe a more complex and interesting place. As we depart from the magnificent realm of Orion, we carry with us this deep understanding. We have witnessed both the cradle and the grave of stars. We have seen the dying embers of a supergiant and the first light of newborn suns. This eternal cycle of birth, life, and death is the engine that drives the evolution of the galaxy. It is this process that allows for the formation of rocky planets like our own Earth and provides the chemical building blocks for life itself. The story of Orion is the story of our own cosmic ancestry, written in fire across the heavens. Our solar system has a cosmic address. Earth orbits the Sun, which lies in a quiet suburb of the Milky Way, about 27,000 light-years from the galactic center. We're far from the chaotic core, yet close enough to star-forming regions for life to arise. This prime galactic real estate may be essential for complex life to flourish. Our solar system drifts through the Orion Arm, a minor spiral arm of the Milky Way, named after the Orion constellation. We live on a quiet galactic side street between the larger Sagittarius and Perseus arms. The Orion Arm is home to our Sun, Alpha Centauri, and most stars visible from Earth. Here, we enjoy a stable, less crowded region, safe from the chaos of major arms. Our Sun is just passing through on its grand journey around the galaxy. Just as Earth orbits the Sun, our solar system orbits the Milky Way's center, home to a supermassive black hole. This journey takes about 230 million years, a galactic year. Each lap, our Sun and planet speed through changing cosmic environments, shaping Earth's history. Our voyage through the galaxy is the silent rhythm behind life on Earth. The concept of a habitable zone is familiar to us on a planetary scale. the Goldilocks region, around a star where temperatures are just right for liquid water. But astronomers have extended this idea to a much grander scale, the galactic habitable zone. This is a theoretical ring within the galactic disk that is considered the most likely place for complex life to emerge and thrive. It's a region that strikes a delicate balance between two opposing requirements. On one hand, you need enough heavy elements to form rocky planets. On the other hand, you need to be safe from frequent, life-sterilizing cosmic events like supernova explosions. The inner regions of the galaxy, near the central bulge, are rich in heavy elements, or metals. Star formation has been vigorous there for billions of years, creating plenty of the raw materials needed for Earth-like worlds. However, this region is also incredibly dangerous. The density of stars is very high, increasing the risk of gravitational disruptions from close stellar encounters. More importantly, the rate of supernovae is much higher, bathing the region in lethal radiation. It's a chaotic, violent downtown core where life would struggle to get a foothold and survive for long. The inner galaxy is likely too hazardous for complex life. Conversely, the outer regions of the galaxy are much calmer and safer. Supernovae are rare, and stars are spread far apart. However, this region is metal poor. Star formation has been less efficient here over the galaxy's history, so the interstellar gas is not as enriched with the heavy elements forged in stellar cores. There may simply not be enough silicon, iron, and other heavy materials to form large, rocky planets like Earth. While the outer galaxy is a peaceful suburb, it may lack the necessary building materials for worlds that can support life. It's a pristine but potentially barren wilderness. The galactic habitable zone is the sweet spot between these two extremes. It's a ring located at an intermediate distance from the galactic center, a region that includes our own solar system's position. Here, there is a sufficient supply of heavy elements to build terrestrial planets, but the environment is stable enough, with a low enough rate of supernovae and other disruptive events to allow life to evolve over billions of years. The very existence of life on Earth suggests that we are indeed located within this zone. Our galactic address, it seems, is not a coincidence, but a necessary condition for our own existence. Our journey now leaves familiar scales behind. We've seen stars like our Sun, but hypergiants dwarf even those, colossal, rare, and short-lived titans that push the limits of physics. Imagine a star so vast it could swallow our entire solar system, making the Sun seem tiny. These stellar leviathans are incredibly rare, true giants among millions. Prepare to witness a scale that forever changes our sense of the cosmos. Deep within the Milky Way, in the constellation Scutum, lies UY Scuti, the largest known star by volume. This red hypergiant is about 1/1700 times the Sun's radius and could fit nearly 5 billion suns inside. Unlike our Sun, UY Scuti is a vast, diffuse globe, shedding mass and glowing with incredible luminosity. It pulsates and changes brightness, nearing the end of its life. Soon, UY Scuti will explode in a spectacular supernova, ending its reign as the galaxy's largest star. Massive stars like UY Scuti live fast and die young. Born with immense mass, they burn brighter than millions of suns, but only for a few million years. Their lives end in spectacular supernova explosions, leaving behind neutron stars or black holes, the cosmic forges of new elements, and the universe's most mysterious objects. UY Scuti is massive, but it's not alone. The galaxy hosts other titans, Wolf-Rayet stars, stripped to their cores by fierce winds, and luminous blue variables erupting with energy. These rare giants shape the galaxy, forging heavy elements and leaving behind neutron stars and black holes. Their power and beauty are truly cosmic. Our journey has taken us across the Milky Way, from the Orion Arm to the galaxy's heart. Now, we approach the center, a region of extreme energies and impossible gravity. Here lies Sagittarius A Star, the supermassive black hole at the core of our galaxy. Our journey now takes us face to face with this gravitational monster. At the heart of our galaxy lies Sagittarius A supermassive black hole, the invisible anchor holding billions of stars in orbit. Its gravity is so intense, not even light escapes. Sagittarius A contains 4 million times the mass of our Sun, packed into a tiny space. It shapes the Milky Way, a humbling reminder of the universe's mysteries. The event horizon is the black hole's point of no return, an invisible boundary where nothing, not even light, escapes. Surrounding it, the accretion disk glows brilliantly as matter spirals inward. Thanks to the Event Horizon Telescope, we've seen the shadow of a black hole, revealing the heart of our galaxy. A sleeping giant shaping the Milky Way. While Sagittarius A Star is the gravitational king of the galactic center, its mass alone can't explain everything we observe about our galaxy's motion. The stars in the outer regions of the Milky Way are orbiting the center far faster than they should be, based on the amount of visible matter, stars, gas, and dust that we can account for. If the visible matter and the central black hole were all that existed, the outer stars should be flung off into intergalactic space. The fact that they're not tells us there's something else there, something massive and invisible, whose extra gravity is holding the whole galaxy together. This mysterious substance is what we call dark matter. The galactic center is a key place to study the interplay between ordinary matter and dark matter. While the supermassive black hole dominates the gravity in its immediate vicinity, the broader region of the central bulge and the galaxy as a whole is governed by this invisible halo of dark matter. Current theories suggest that dark matter forms a vast, spherical cloud that extends far beyond the visible disk of the Milky Way, acting as a cosmic scaffold upon which our galaxy was built. The nature of dark matter remains one of the greatest unsolved mysteries in all of science. It doesn't interact with light in any way, making it completely undetectable by conventional means. Some scientists, however, explore alternative ideas. Maybe our understanding of gravity itself is incomplete. Theories like modified Newtonian dynamics, or MOND, propose that gravity behaves differently on very large scales than predicted by Einstein's theories, eliminating the need for dark matter altogether. These alternative gravity theories are a minority view, but they highlight our quest to understand the universe's fundamental workings. The galactic center, with its extreme gravitational environment, is the perfect laboratory to test these competing ideas and push the boundaries of our knowledge, forcing us to question our most basic assumptions about the cosmos. As we pull away from the brilliant, chaotic heart of the Milky Way, we're left with a sense of profound mystery. We faced the supermassive black hole, a known but barely understood entity, and we've been reminded of the even greater mystery of dark matter, the unseen skeleton that holds our galaxy together. The journey to Sagittarius A has shown us that even in the most luminous and densely packed regions of the cosmos, the greatest secrets often lie hidden in the darkness. We visited the engine room of our galaxy, and we found that it's powered by forces we're only just beginning to comprehend. Pulling away, we see the Milky Way's grand design, a barred spiral galaxy. Its central bar shapes the galaxy, with spiral arms sweeping outward, filled with stars and nebula. Our sun drifts in one of these arms. The galaxy's thin disk spins within a vast, invisible halo of dark matter, which holds everything together. To truly understand our galaxy, we must look beyond the light. At the heart of our galaxy lies the central bulge, a dense, ancient sphere of stars surrounding a supermassive black hole. Unlike the orderly disk, stars here move chaotically, revealing the Milky Way's oldest history. Cutting through this bulge is the stellar bar, a vast, elongated stream of stars shaped by gravity, stretching over 20,000 light-years. The bar acts as a gravitational engine, funneling gas inward, fueling star formation and feeding the black hole. Recent observations show the bulge's X-shaped structure, a direct result of the bar's dynamic influence. By studying these central stars, astronomers piece together the Milky Way's evolving story. Beyond the bright disk lies the galactic halo, a vast, ancient sphere of stars, relics from the Milky Way's earliest days. These stars on wild, plunging orbits are fossils of the galaxy's violent formation and mergers. Scattered throughout are globular clusters, dense, glittering spheres of hundreds of thousands of ancient stars. The Milky Way hosts about 150 of these clusters, each a cosmic time capsule. Studying them reveals the minimum age of the universe and the galaxy's assembly history. The halo and its clusters are living records of how our galaxy grew from smaller building blocks. All the stars and gas we see are just a fraction of the Milky Way's mass. Enveloping everything is a vast, invisible, dark matter halo, making up about 95% of the galaxy's mass. We can't see dark matter, but its gravity holds the galaxy together and shapes its evolution. This unseen halo is the true architect, drawing in ordinary matter to form stars and galaxies. The nature of dark matter remains a cosmic mystery, with scientists searching for its elusive particles. Solving this puzzle will transform our understanding of the universe's structure. For millennia, the Milky Way was a celestial mystery, seen as a river of souls or spilled milk in ancient myths. Everything changed in 1610 when Galileo's telescope revealed the Milky Way as countless stars, not a cloud. This discovery shifted our view from myth to science, sparking questions about the galaxy's true nature. In the 1700s, thinkers like Thomas Wright and Immanuel Kant proposed the Milky Way was a disk of stars, and that other nebulae might be distant galaxies. William and Caroline Herschel mapped the galaxy, revealing its flattened shape, though their view was limited by interstellar dust. Their work laid the foundation for future astronomers to unravel the Milky Way's structure. The journey from myth to map had begun. As telescopes improved, astronomers debated the true nature of spiral nebulae. Were they part of our galaxy or distant island universes? In 1920, the Great Debate pitted Harlow Shapley, who saw the Milky Way as the entire universe, against Heber Curtis, who argued these nebulae were separate galaxies. The debate was unresolved until Edwin Hubble used a powerful telescope to find Cepheid variable stars in the Andromeda Nebula. By measuring their brightness, Hubble calculated Andromeda's distance, nearly 1 million light-years away. This proved Andromeda was a galaxy far beyond our own. The universe was suddenly much larger, filled with countless galaxies. Our cosmic perspective was forever changed. Hubble's discovery showed we're just one of billions of galaxies. Mapping our Milky Way became crucial, but dust blocked our view. Radio astronomy let us see through, revealing the galaxy's spiral arms. Today, missions like Gaia map over 1 billion stars, creating a dynamic, three-dimensional portrait of our galactic home. The Milky Way's story began over 13 billion years ago, in a universe filled with diffuse gas and dark matter. Gravity drew these clouds together, igniting the first stars. Through countless mergers and cosmic collisions, chaos slowly gave way to order, transforming clumpy proto-galaxies into the majestic spiral galaxy we call home. A history of cosmic cannibalism. The Milky Way is a cosmic cannibal, growing by absorbing smaller galaxies over billions of years. Its history is written in the stars of its victims, shredded and absorbed by tidal forces. The Sagittarius dwarf galaxy is being torn apart, its stars forming a vast ribbon, the Sagittarius stream, wrapping the Milky Way. These stellar streams are fossils of past meals, showing our galaxy is dynamic, built piece by piece over cosmic time. The Milky Way and Andromeda galaxies are on a collision course, drawn together by gravity despite the universe's expansion. In about 4.5 billion years, they'll begin a slow, spectacular merger, passing through each other like ghosts. Tidal forces will pull out vast streamers of stars and gas, reshaping both galaxies. Eventually, they'll form a single giant elliptical galaxy, Andromeda, forever changing our cosmic neighborhood. In billions of years, the Milky Way and Andromeda will merge, reshaping our galaxy. By then, Earth will be uninhabitable, and the stars will slowly fade away. Yet, in this fleeting cosmic spring, life and consciousness have emerged. Our true legacy is our capacity to wonder, to explore, and to cherish our brief moment of light in the universe. Our epic journey is complete. We've soared from the solar system's familiar shores to the heart of the Milky Way, witnessed stellar birth and cosmic collisions, and returned home forever changed. The galaxy is not just something we are in. The galaxy is in us. Earth is our sanctuary, a precious outpost of life in a magnificent city of stars. From the edge of our solar system, Earth is a tiny, pale blue dot, our only home, suspended in a sunbeam. On this small stage, all of human history has unfolded. This perspective is a powerful lesson in humility and unity. We are all crew members on this fragile world, sharing a journey through the cosmos. Our existence here is a testament to the universe's wonder and our shared responsibility to protect it. Our journey around the Milky Way may be over, but the human voyage of discovery has only just begun. We live in a golden age of astronomy. Every day, new telescopes on the ground and in space are pushing the boundaries of what we can see, revealing new planets, new stars, and new galaxies, and answering old questions while posing new, even more profound ones. We have mapped the shadow of a black hole. We have detected the gravitational echoes of cosmic collisions, and we are charting the positions of 1 billion stars. We stand on the shoulders of giants like Galileo, Herschel, and Hubble, continuing their quest to understand our place in the universe. This quest is driven by one of humanity's most powerful and noble impulses: curiosity. It is the same impulse that led our ancestors to look up at the night sky and wonder. It is the desire to know what lies over the next hill, across the next ocean, and beyond the next star. This innate curiosity is our engine for progress, pushing us to build better tools, to ask deeper questions, and to dream bigger dreams. The universe is the ultimate frontier, and its exploration is a journey that will likely never end. There will always be new mysteries to solve and new wonders to behold, just beyond the edge of our current knowledge. What does the future hold for humanity's cosmic journey? Perhaps one day, our descendants will make these journeys not just in their imaginations, but in reality. Perhaps they will build starships capable of crossing the interstellar void, visiting the worlds of Alpha Centauri, or even witnessing the glories of the Orion Nebula up close. Perhaps they will become a multiplanetary and eventually an interstellar species, carrying the seed of terrestrial life out into the galaxy. The challenges are monumental, but the history of our species is a history of overcoming seemingly insurmountable obstacles. The dream of the stars is a powerful one. So the next time you stand under a clear, dark sky and look up at that faint, milky band of light, remember what you are seeing. You are looking into the heart of a colossal, spinning city of stars. You are seeing your home, your history, and your destiny written in light across the heavens. Remember the journey we have taken, the wonders we have seen, and the profound perspective it offers. Keep looking up, keep asking questions, for the voyage is unending, and the cosmos is waiting.